Hello, so this is a short video about the binary system and also about Ascii code. So one thing, with all the riddlers and all of that, they tend to use sometimes binary code, which isn't hard or anything or mysterious. It's basically just a number system. And as we know the decimal system. Our decimal system is very simple, more or less. It's the base of our decimal system is decimal 10. So it's quite simple. So we've got the base is 10, meaning that the first, so as we know, if we read the number 1 to 3, we know we have 3 of the amount 1, 2 of the amount 10, and 1 of the amount 100. So each position, each number position has the value of, the first number position has the value of 10 to the power of 0, which is 1. Then the second position has the value of 10 to the power of 1, and then we have 10 to the power of 2. So meaning that if we have 1 to 3, so 123, it is basically 3 times 1 equals, it's basically translates to 3 times 1 plus 10 times 1, because and that maybe I'm just gonna switch the positions here. So 1 times 10, and then I meant 2 times 10, and 1 times 100, and we add all of that. So meaning that we have, so if we have 3 to, so 1 to 3, so 123, it's 3 times 1, 2 times the 10, and 1 time the 100. And that's basically how it works. And now we have the same for in the binary system. The base is 2, meaning that the first number, so first number position, has the value 2 to the power of 0, which is 1. Then we have 2 to the power of 1, 2 to the power of 2, and so on. 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and so on. And now we do have here 2, 4, 6, 8. So we do have here 8 binary digits each. So this, okay, right. So now we can quickly, so it will go until 2 to the power of 7. And we can translate that basically, so now we have these here, and with 8-bit, because 1 bit can represent 0, 1, and with 8 bits, with therefore 1 byte, meaning that they can represent 2 to the power of 8 different combinations, equals 256. So we do have 256 combinations of the 00001. So if just have to check, yes. So we can do it like that. I meant so we do have one with only zeros, one with the 1, and so on. So we can basically keep going here. So if we would count, this is 0, this is 1, then this one is 2, then that one is 3, and so on. So we would be keep counting and up there. So we can represent numbers from 0 to 255, which were over 256 different numbers. So now let's go to the part here. So we will translate that. So we will do it for one number. The rest we will do automatically later. So if we now take the number here, we do have here 1. So we just add all the numbers. So it's 1. We have a 1 here. So 1 times 2 to the power of 1 is 2. So plus 2. So 2 plus 1. So let's go on here. That one is 4, 8, 16, 32. So meaning that plus 32. So let's continue, and then we have 64. And now then we have 0 again, and then it doesn't matter. So now we just add all these things here together. So now we're calculating the decimal system, because it's easier for us. So 1 plus 3 plus 32, 35 plus 64, 99. I hope it didn't make a mistake here. No, it didn't. Okay, 99. And now that's the easy part here. So there's something called the Ascii Table, the American Standardization Code of Inter-Exchange, I think. We'll just look it up one more time. It's called the American Standard Code for Information Interchange. My bad. And basically, it maps just to the values a character. And that's how it basically works. So we are just going to look up the Ascii table. So we can just look at any simple table here, right? That's a great website here. So we can see, for example, 99 translates to a uppercase to a lowercase c. and so on. And that's basically how it works. And there are tools out there which help you. So therefore you can just take all of that stuff here, copy and paste it into that tool here. We'll also link it here. So we'll paste the binary bytes, click on OK. And we can see here, this one translates to crypto is here to stay. So this was just a basic tutorial. This is not an encryption, this is a so-called encoding. Okay, so just because you translate it into a quote-unquote cryptic message does not mean it's encrypted. It's just, like I said, in encoding. There's just a computer standard which is being used for characters by computers, and that's basically what is being used here. So I hope this was, well, insightful, interesting, or also interesting to understand the background of how all of that works. On a side note, I will also mention now quickly hexadecimal. So hexadecimal is basically this, it's basically the same again, but hexadecimal, as it says, hexa and decimal, so 6 and 10, has the base 16. So the first place has the value of 16 to the power of 0, and the second place has 16 to the power of 1. So right, and so on. So it's easier. So you can just, for example, with hexadecimal, you can represent the 256 different states with only two places. So we can with just 2-digit places. So from 000 to until FF. So that's the last one. So a hexadecimal system goes from 0 to 9 and from A to F. So these are the valid characters you can use basically. And 0 representing 0, and an A representing 10, and an F representing 15. But that's just on a side note. So thanks for watching, and see you in the next one.